In this video, we're going to talk about section 10.1, distance and midpoint formulas. Our first goal is going to be using the distance formula to find the distance between any two coordinates on the coordinate plane. In the following box here, you have the distance formula that is between two coordinates, and the two coordinates are called x1, y1 and x2, y2. Remember, those 1s and 2s are called subscripts. It's just a way of telling the difference between the x coordinates of one and the x coordinates of the other, and so on. If you look at the formula, it looks kind of complicated, but actually it's not. All you're doing is you're square rooting the difference of the x coordinates squared and adding that to the difference of the y coordinates squared. So let's apply it in example 1. We're going to find the distance between the coordinate 4, -5, and -2, and 7. Notice the first thing they do is they let x1, y1 be the first coordinate, and sometimes I just write right above the coordinate x1, y1, so I know what I'm dealing with. And the second coordinate, x2, y2, is going to be the -2, 7. So my x2, y2 are the -2 and 7. If we apply it in the formula, we're going to end up with the square root of, instead of x2 minus x1, x2 is -2. So I'm going to put in -2, then minus the x1 coordinate or value 4. So I'm going to have -2 minus 4 in parentheses squared to start, then plus, now I'm going to do the difference y2 minus y1. That's going to be 7 for y2 minus the y coordinate -5. Now this is where you got to be careful. We're going to subtract a -5. So you probably are thinking right now, you know, when you subtract the negative, that's going to be just a big positive. And don't forget, we have to square that at the end. So what we're going to have then, if we simplify, is we're going to have -6 that we have to square in the first set of parentheses, and in the second set we're going to have to do a 12 squared. You know that's going to be really a 36 plus, and 12 squared is 144. If you add 36 and 144, you get the square root of 180, I think. Now, that's your final answer. What I would ask that you do is, if possible, let's simplify the radical. Now, this is a nice review. If you remember breaking down radicals, we would pull out any perfect squares. In this case, I'm going to break it down by doing 18 and 10. 18 I know is 9 times 2. 10 is a 2 times a 5. Right away I know I can pull out a 3 from the 9 and a 2 because I have a pair of 2's, right? Really, there's a 4 inside that's a perfect square of 2. So I can pull out a 3 and a 2, and I'm left with the square root of 5. So that would be, really, if you multiply, 6 square root of 5. In decimal form, if we were to use our calculator and just type in the 6 square root of 5, 6 square root of 5, that would be 13.42 to 2 decimals. So let's go 13.42 approximately is the distance between those two original coordinates. So hopefully seeing one example should be enough to get the idea. Let's go on to the midpoint formulas. If you take a look at the following midpoint formula, it says the midpoint of a line segment that's drawn on the coordinate plane that joins point A at x1, y1 and coordinate B that's at x2, y2, will have this middle coordinate, so the point that's right in between the two. Now, when we talk about a midpoint in geometry, we've never seen this maybe notation yet. Some of you might have. But if I wanted to show that that midpoint is in fact right in the middle of that segment, I'm going to use these little tick marks. That's saying that the length from A to M, so that segment AM, is exactly the same length as it is from M to B. So AM equals MB. Those lengths are exactly the same, making M the midpoint of the segment. In order to find the coordinates of the midpoint, all you have to do is add the x coordinates of each of the endpoints and divide by 2, and add the y coordinates of each of the endpoints and divide by 2. If you think about it, all you're really doing is you're taking the average. You're taking the average of the corresponding coordinates of A and B, meaning you guys know the average of two numbers is just when you add them together and divide by 2. That's essentially what you're doing here. You're adding the x coordinates together, dividing by 2. That's the average of the x coordinates. Same thing for the y coordinates. We're doing the average of the y coordinates. Take a look at example 3 with me. Now, they drew you a nice picture of the segment that has endpoints -3, 5, and 1, -4. We want to find the midpoint, which would be somewhere in here. I don't know exactly where it is. The cool thing is, if we use the formula, we won't need to actually graph anything. We can just plug in the numbers where they belong. Now, to use that formula from above, it's a good idea to label each coordinate as either x1, y1, and x2, y2. In this case, I'm going to let 1, -4 be our x1, y1, and let -3, 5 be the x2, y2, so I can plug it in the formula. The midpoint formula is restated right here for you. So if we do the average of the x's, x1 plus x2, really I'm going to do x1, 1, plus the x2 value, -3, and divide that by 2. That's going to be the x coordinate. The y coordinate is going to be the average of the y values, -4, plus the y2 value of 5. So again, all I'm doing is substituting in my y1 and y2 values where they go. And if we simplify this, I really get -1 plus 3, that's -2 over 2 for the first coordinate. -4 plus 5 is 1, and 1 over 2 for the second. So if you simplify all the way, that's -1, comma, a half. That would be your midpoint. Notice the midpoint, unlike distance, is an actual coordinate. It's got an x coordinate and a y coordinate. If we plotted that, let's actually see where that would have landed. -1 up a half, that actually is right on our graph, and it looks like it is right in the center. And so that's how you find the midpoint of a segment using the formula. Let's do another last application of distance and midpoint, and we can do this to find a perpendicular bisector. And so here we have a little vocabulary we have to talk about. For example 4, it says, write the equation for a perpendicular bisector of the line segment that joins A, -2, 3, and B, 2, 5. Guys, let's talk about something real quick. And on the side here, let's say this is coordinate A, and I have another coordinate over here, B. If I were to draw a line segment that connects the two, it would look like that. When I have a line segment, I can try to find the perpendicular bisector. Now, you may not know what perpendicular means, or some of you might. Perpendicular is just a fancy way of saying we have a 90-degree intersection. And a 90-degree intersection is just what's called a right angle. A right angle, guys, is like a quarter turn. It's like a corner of a piece of paper, okay? And when you bisect something, this literally translates to cut in half. So if we have a perpendicular bisector of the segment AB, I want to draw a line that not only intersects the segment AB at a 90-degree angle, but it also cuts it right in half. Well, if you think about it, if I'm going to cut AB right in half, that means I'm going to hit that middle point that's right smack dab in the middle of A and B. We already know that point is called the midpoint, right? That's your midpoint. Let's just say M for right now. So our perpendicular bisector is going to have to go right through there. Let's use a different color. So if I draw my perpendicular bisector, that's going to go right through that midpoint. It's got to split it in half. Remember, this distance and this distance would be the same. And it would also have to be at a 90-degree angle. To show that that's 90, we use that little corner like a box. That just indicates, hey, that's 90 degrees. It's like the corner of a piece of paper. It's that same angle. So we're going to try to find what is the equation of such a line. That is called the perpendicular bisector. All right. Well, it's not that complicated, although we do have to do a series of steps. As you saw in my illustration, in order to get the perpendicular bisector, you have to find the midpoint. So the first thing that we can do is calculate the midpoint of the line segment. Let's call A x1, y1, and point B, the coordinates, x2 and a y2. Sorry, my pen's not registering very well right now on here. So if I substitute x1 and x2 in, I'm going to end up with -2 plus 2 over 2 for the x coordinate, and if I add the y's, I get 3 plus 5 over 2, which is going to end up being 0 over 2 for the x coordinate and 8 over 2 for the y, which, let's just write the final answer here, that would be really 0, 4. Guys, this is our midpoint. So we just did a little midpoint problem here. Now, the other thing I'm going to try to do is calculate what is the slope of this perpendicular bisector line going to be. Remember, to find exactly the slope of it, we need to know the rise and the run. And you may have forgotten, but there's a relationship between the slopes of perpendicular lines. This perpendicular bisector, that red line, is perpendicular to the line AB that connects the coordinates AB. Now, so I'm going to find the slope of my perpendicular bisector in a roundabout way. I'm going to first calculate the slope of my AB segment. That means I'm going to use the slope formula, change in y over change in x. Using the coordinates for y2 and y1, I can use 5 minus 3, that's y2 minus y1, over x2 minus x1, that would be 2 minus the -2 from above. So that's really 2 over 2 minus -2 is really 2 plus 2, that'd be 4. That reduces to a half. So the slope of the segment AB is a half. You may have forgotten, when lines are perpendicular, however, the slopes of perpendiculars are opposite, they're opposite reciprocals of the existing line. So the slope of the perpendicular bisector is going to be the opposite reciprocal of 1/2. So the opposite reciprocal, remember, means you make it the opposite sign, which in this case would be negative, and then I would flip the fraction to make it 2 over 1, which is just the same as -2. And by the way, the short way of writing slope perpendicular is using this little symbol here. It's like an upside down T, and that symbol, upside down T like that, literally means perpendicular. And if you think about it, it kind of makes sense, because the upside down T does have like a little 90-degree intersection, like with the vertical line and that horizontal base to it. So just know that we can write the perpendicular slope with the M and that little perpendicular symbol. So guys, if you think about it, we are in good shape to write the equation of this line, because we know what the slope is. It's -2, and we have a point that's on the perpendicular bisector, which is the midpoint. So we can use point slope form to write its equation. If you forgot point slope form, let's write it in here. It's y minus y1 equals the slope m times x minus x1. So let's actually plug in the values we know. We know the slope is -2, and the coordinates of the point on the line we call x1, y1. Guys, here you want to use the midpoint. That is the line, or excuse me, the point that we know is on our perpendicular bisector. So let's use that midpoint, which, if we look back at what we calculated above, remember our midpoint was 0, 4. So, oops, I'm going to use 0, 4. So if we substitute in those values, it's going to be y minus the y1 value, 4. This is my x1, my y1, equals the slope, negative 2, and then times x minus the x1 value of 0. So I get y minus 4 equals, really x minus 0 is just x, so I get y minus 4 equals negative 2x. I'm going to add 4 to both sides, and my equation becomes y equals 2 times x plus 4. That would be the equation of the perpendicular bisector to the line segment that joins those 2 points. Okay, that's probably the toughest problem you're going to see from this section. I'm going to see how well you guys do on your self-quiz. Built in each of those, between each of those examples were some checkpoints. So please try, if you didn't already, the distance for number 1 between those 2 points. For number 3, you're just finding the midpoint. And for number 4, you're trying to find the equation of the perpendicular bisector that joins point A and point B, which is the very same problem that we just went over. Do your best on it, and we'll talk about it tomorrow. Thanks for watching.